Hello, everyone. Welcome to our fifth Community Friday. We're very excited to be here and thank you for joining us. My name is Mimi and I'll be your host today. So we actually have something very special planned today. But first, let me go through the quick house rules as usual, if this is your first time joining us. So usually we would like to share some of the stuff that we've been working for the past 2 weeks with our community here. So the general house rules is one, we will show you what we shared in the past 2 weeks. So how did we make the robot better? We would also like to share some of the things that we are still figuring out, some of the things that we find challenging. And thirdly, of course, we would like to show you some of our demos, some visuals that we've been working on. So today's agenda is we will be focusing mostly on hardware. We have a lot of exciting updates on hardware side, but also importantly, we have a special guest today. We invited somebody who has been very active in our community, but more on that later. And then we will, of course, have our usual housekeeping session where we will just have general questions, some career opportunities, or just general Q&A. All right, then now I'll pass on to our first team, hardware.
Hello, everyone. It's nice to see everyone again after 2 weeks. Mimi, can you share my screen? I think we'll start off with some updates on the physical hardware itself, and followed by locomotion/hardware testing, and finally the new stuff we're working on in the Menlo. So we've previously released the motion control board, I think about 2 weeks ago, but we're currently working on probably the final iteration of it. We've simplified a lot of things. We've managed to get a firmware image such that you only need to flash the board with USB-C. So no SSH access, nothing, and you can set up the whole board. There's no longer any weird connectors for each of the individual CAN buses. On the right over here is the head for the motion control board. So if you see these connectors, it'll sit very nicely onto the board itself, allowing you to just plug in both power and data communication directly to the board. So LL here stands for left leg, left arm, etc., etc. And this spot over here, I'm not sure if you guys can see my video, but it's for this relay right here. And this allows you to turn on and off the motor fully through software. On probably what was really challenging this week is that we actually had one of our motion control boards fried on the 3.3 volt line. So what we did was that we swapped it out for a better LDO. So this guy over here. So instead of 1 amp, now it's capable of doing 2 amps and has much better heat dissipation. So hopefully that problem will go away. But of course, hardware testing will continue and you never know when things will change. Oh yeah, and we have nice pins at the bottom here for serial debugging. You just solder wires and it can work. Ishit, do you want to share on locomotion training?
Yes, I'll start off with sharing the work we did on the software setup this week. So as we know, we are closer and closer to shipping Asimov 1, and we need to get all the software pieces in line for it. So that is basically, we have two boards. We have the motion control board and the Raspberry Pi. So we want to make the process as seamless for the user that is setting up the robot for the first time. So eventually we will provide the image for the motion control board, and the Asimov API will be open sourcing soon. So all you'll really have to do is, you flash the motion control board with the image we provide you. All the instructions are here. Then you flash the Raspberry Pi with the image available online from the Raspberry Pi documentation. You set up the network so that the Raspberry Pi can talk to the motion control board, and then you install and run the Asimov API on the Raspberry Pi. And so all this does is then everything is set up for you, and you can use LiveKit to be able to control the robot by spinning up your own LiveKit server or hosting one in the cloud. And so this is what we worked on this week for the image and the software setup regarding the robot. And then on the side of the locomotion, we actually have some good progress this week. We're able to walk the robot, and it doesn't lean forward anymore. So I think this week there was a lot of targeted A/B testing. We were swapping out different components using different actuator models, testing different amounts of center of mass domain randomization we do. So as you can see, it still drifts in the video, but drift is another problem that is independent of what we were trying to solve. What we were trying to solve was whenever it used to walk forward, it used to take one or two steps and it would never be able to actually catch itself. And now we have actually solved that by doing some targeted center of mass domain randomization and making sure the policy learns a dynamic that it leans back more while it's walking. So you can actually see it's quite stable in this video, and we are closer and closer to actually bringing it out into the wild.
I think I can share the next. So just some quick update about the menu, and we have two big updates. The first is, as Ishni mentioned, we now have the instructions on how to set up the motion control board and also the Raspberry Pi and Azimuth API, including like installing images to Raspberry Pi and motion control board. And another update is from my side. I remember Mendo discussing the channel that he wants some interactive views for like during the assembly steps. Otherwise, it's kind of hard to find the parts based on just the file names. So now we have it. So I loaded the parts in GLB file and coded this in 3JS. So like it's rendered by 3JS. And once you click the file, you will see the file name. And it's very easy for you to find what is missing by just clicking it. And also I include the information of the fasteners, so you can check what is the part for the fasteners and what is the quantity of it to double check before start assembly. And another update I'm doing is for the wires. I think as you might notice, I actually put some wire instructions along with the mechanical drawings, because wire is one of like very important step along with the mechanical assembly. It's not separable. But after inspired by like Mendo, I was thinking maybe in this way it might seem a bit vague and maybe it's not clear enough. So I was working on the wiring views like this. So you can just rotate it. I will embed this page into the menu soon. So like in this way, it's very easy to see what are the ports in the motor. You can just click and you will see what is the motor for this. And it will also check and you can also see the connector information. For example, here I need a straight connector, and you can just prepare your wire in that way. And also you can get the information of wire length and if the wire is prefabricatable or not. So some wires require you to make along with the assembly, and some you can just pre-make. Yeah, I hope this helped. And please let me know if you guys have any feedback and what can make your life easier for the assembly parts.
I think we have some questions in the chat. Yes.
Yep, I can take this. So, a question from Seeking Cashflow. How come in the roadmap the API was first before sharing locomotion policy? So the reason why we want to share the API first is that the robot isn't only about walking. I mean, obviously people want to walk the robot around, but people also want to train their own locomotion policies. Let's say they want to have more human interaction with the robot sitting on a couch. And we felt that releasing the API first at least gives people a good idea of what they can expect. We still have not released the source files for the API yet. Hopefully we'll do it within the next 2 weeks. The reason for the delay is that we're hoping to release this along with our own simulation in the cloud. So this will be based on Fulyoko, and it'll allow people to actually run the API and test what's actually happening on the robot on their browser itself. And we'll have some interactive code examples which directly link from the manual. So it's easy for you to see what line of code change corresponds to what physical characteristics.
Please feel free to drop more questions in the comments. Oh, Seeking Cashflow is asking another question.
Okay, so from Seeking Cashflow again, can you guys explain a little bit the connectivity from the API and motion control board? So currently the way it works is that the motion control board is the one in charge of communicating with the motors, running the locomotion policy, and basically making sure the robot doesn't crash and burn, and you don't send a weird command that moves the robot into itself. It's also monitoring the BMS activity. And the data from this is then sent to the head of the robot. The robot will ship with a Raspberry Pi 5. You can also install any other computer you want on it. As long as it's Linux, you'll able to actually run Asimov API. So you can think of Asimov API like a client SDK for the robot itself. If you don't want to use it, it's still okay. You can actually write your own client SDK on top of the motion control board's API. The difference between the two is that the motion control board is much more low level and is designed for like C system programmers. But the Asimov API will most probably be, I mean, it currently is a Python API and we'll probably keep it that way, just so that it's easier for you to either vibe code or, I mean, for beginners to actually interact with them. But we just don't want to limit what you can do with them. That's why we have this separation between the computer in the head and the computer in the body. Yeah. So the motion control board is the real-time piece. It makes sure that everything always works, and any user code you load onto the Raspberry Pi doesn't stop the robot from working.
Okay, if nobody has any more questions, or please feel free to continue dropping the questions and then we'll come back to them at the end of our call. But let's move forward to our guest, actually. We have a very special guest, Grafto, who has been very active in our community, and he is actually building the first aftermarket for humanoid robots. He's been doing very cool stuff with Asimov. So Grafto, would you mind sharing a bit about yourself, about your work, and anything else really?
Hey guys, thanks for the intro, Mimi. Yeah, so I'm Grafto. I've been a software developer all my life and I wanted to get out. I found this project and I thought it looked really cool and I wanted to build my own. And I built a little bit of software to configure the body parts as they're open source. I thought I could have a different color robot. And that led me on to the idea of a complete aftermarket for robot customization, which I think will be a really big thing in the future. And currently, I'm 3D printing my own miniature Asimov robot, just as a mannequin to dress up with the body kits that I plan to create. And I'm also dabbling in vinyl skins that can lay over the top of robots and may even go into clothing at some point. So I'd quickly screen share some of the work that I've been doing. So this is the website. And yeah, I've just put a bunch of the previews of the generations that I've been putting up here. And these are the sort of robots that I imagine we might be able to build in the future. And I very much hope that we can, especially with robots like Asimov, which make it easy for tinkerers to be able to go in and change things. So you can feel free to check this out at graphlab.com. And a little bit of the software that I do. So I'm unwrapping the UV of the robot, allowing me to go in and make changes and add things to the robot, and then I'll apply these skins. Oh, a little bit of an error there. And then when I change this, it kind of gives me what I need for the vinyl wraps. And in terms of the robot body kits, I've just gone in and made a little configurator to swap all of the colors. If I select something, that is. And this is basically what I'll be offering to users to go in and customize what they want their robot to look like. And yeah, that's pretty much me. Are there any questions?
What's the most fun or like a bit out there idea for customization do you have?
I guess making robots like this, the ones that we all know and love, I mean, in a world where people are going to be walking around with, well, I assume everybody's going to have a robot in the future, like everybody has a mobile phone, everybody has a car. It'll be really interesting to see what people do in terms of customization, and I don't think we'll see one robot that looks the same, except for the ones that come off the market like this.
Do you feel like in the future, so we're talking about maybe somewhat fantastical, do you feel like people's emotional relationships with robots might change if, they are more able to customize the robot?
Yeah, definitely. Right now, a lot of robots coming out looking the same, and to me, they all look very industrial. They're either black and white or slate gray, and they don't really have any emotional soul to their face. I think customizing them this way will bring a lot of personality to them and help people feel a little bit less uneasy. And also in terms of personal robots. I think companionship is going to be a huge market. There's also already people talking to AI day to day in favor of speaking to humans. So I think having a physical embodiment of AI and someone really knows you, learns you, and gets to know you is going to be a big thing in the future.
So, Russell, from our side, what can we give you? Like, what modifications can we make on the robot itself to enable something like this? Like, I mean, robot skins are really cool, right? I would love to have like a Gundam variant robot or like a Star Wars based robot sitting in my home.
Yeah, so initially I was hoping that robots would have some sort of snap fit point or something I could mount these body kits onto. But I've been speaking with a professional cosplay CAD designer who's helping me build these out now. And he suggests that we can just interlock these pieces. So along the like, if you've got a leg piece, or if I take a body piece of Asimov, the same way that this front bit clips on here, we would do the same for the body kits, and they would just wrap around, connect to each other, and these would be hot swappable. So instead of fiddling around with mechanics and tools, these would be completely toolless and easy to use for anybody, as easy as putting on a phone case.
I see. Okay, that makes a lot of sense. Yeah, we'll keep that in mind. I mean, there's maybe not for SBOF 1, but for future iterations. We could change the geometries of the robot shape itself to allow the snap fits to go on more easily. I think the phone case example is really good. There was evolution, right? The first few phones weren't designed to have a phone case, but consecutively, the shape changed as well.
Yeah, and the same goes for cars. There's a huge car modification scene at the moment. A lot of people just like standard cars, and they buy them and they look the same. But there's still a whole market for people who want to make these personal, change things. And it might not be about the personalization. Some people just love to tinker and they love to build things that look different. And in our day-to-day life, we personalize everything from our hair, skin with tattoos, makeup, our clothing. We decorate our homes. Uh, every human loves to make something feel like their own.
Do you think this is also lead into more 3D printers like entering homes? Like, I mean, we have Bamboo Lab now. It's made 3D printing basically like online shopping. I feel that as robots become more popular, you might see like maybe one 3D printer for every household.
Yeah, I could see that. There are for sure limitations with 3D printing, and I think there's a lot of legislation and laws that are coming in at the moment. So we have to see how the market goes in that direction.
What do you think about like head modifications? Like, let's say you want to swap out a different sensor suite and stuff. Are you planning that as well? I think maybe like a robot based on certain animes. Usually they have like antenna designs and stuff sticking out. It's possible the electronics as well can be embedded into the thing, so it becomes like it's not just cosmetic but also functional.
Yeah, I mean that's moving into the area of animatronics like you might see in Disney World or something, and I think that's definitely an area that will grow. And if not, you could always stick a wig on this. Obviously, there's a lot of issues with body kits at the moment. Some robots are liquid cooled, some require air venting, and there's also the problem of range of motion. I've tried to account for that as best as I could. But ideal, and obviously, if you're adding any sort of mass to a robot, it throws the policies right off. My plan for that is to have NFC tags in each body kit, and hopefully build some sort of dynamic policy which can adapt to each body kit depending on the humanoid that's wearing it.
Yeah, that's a really good idea actually. We could do something on our end as well, for the simulation piece we are planning to host soon, where you should be able to upload the mass of your body parts as well as the files. As long as you state where they're supposed to go, then you can run the locomotion policy to see whether it's compatible with those body parts. And maybe you can fine tune the policy further based on the body kit.
Yeah, I assumed you guys would do something like that. Seeing as Asimov is open source, people are going to be extending the legs, changing the parts, making it different. So the policy will definitely need to change in some way.
Yep, we're planning to make it as customizable as possible. We'll probably add some instructions soon of how you can even take out the neck motors, and you can use it to extend the number of DOF you have on the hands. Sorry, the arms.
Nice. And yeah, that's pretty much me as in a whole.
I think there's some questions for you in the chat. Maybe could we highlight them?
Yeah, so in terms of other robots, the only one that I've looked at because I have the files for is the Unitree G1 and the Unitree Go 2, which is a quadruped. And I do plan to own some of these at some point this year, and I'll be building body kits for those also. My idea is that the aftermarket will be completely universal for all humanoids or quadrupeds.
Oh, I can take this one. So from Nian Ho, how do you guys resolve the latency mismatch between the policy/motor model, usually 50 Hz, and the VLM? Um, I can't speak too much about this right now because we're very much in the testing phase for this. But the idea is that you want your VLM to be running asynchronously, while what runs on the robot is a bit more synchronous. So that way you don't have to rely on both of the frequencies to be matching. It's more of a software engineering problem rather than trying to improve the model itself. I mean, models will improve, but we don't know whether this constraint will ever be lifted. Maybe I think there was a question about fasteners as well for Rafto.
Yeah, so the fasteners can be like what are used for cars. Yeah, I've tried out a few different fastener methods. Initially, I was going with a mounted universal snap-on piece that I would then fit any body kit piece into. But I spoke to the CAD designer that I've got on board, and he says that's probably not the best idea. And we're looking at the pin push fit. So these pieces will wrap around your arm and they slot into each other and then lock into place. And aside from that, to stop the scratching or any shuffle, because obviously there's going to be some gap between the body kit and the robot, there are little foam pads that are going to go on just to prevent any scratches or shuffle.
So on the question of spare parts, we are not sure yet. I think we are still focused on getting our first delivery out before we tackle all these downstream tasks. But once our supply chain is in order, there's probably a good chance that we can provide the kind of spare parts for people. So far in our testing, the MGF parts and /SLF parts have been quite resistant to faults. The only parts we've had to replace are the aesthetic things, which we on like the front covers and the back covers. So from Aryan Madhavan, Madhav, is there any jitter/frame skips that happen because of the policy working asynchronously? Oh, okay. I think this is probably a follow-up from my previous answer. So it's not that the policy works asynchronously, but more of the policy runs in a synchronous fashion, and your higher level LLMs and VLMs communicate with it asynchronously. So the large language models aren't in the same loop as the lower level policies running on them. And this can be your VLAs, your locomotion RL policies, it can also be your whole body controllers.
All right, as we're waiting for a few more questions to come in, Herman, would you mind?
Hi everyone. Hi everyone. I'm Herman here. Very nice to meet all of you again, and so excited you're here for us. So once again, I'm just doing a plug on our open roles right now on our website. So if you see any that kind of jives with you, just feel free to apply for it. We also have a wildcard if it doesn't fit anywhere within your scope or your role. And you can also reach out to me on LinkedIn if you want to have a chat and find out a bit more about the role. Also, I look forward to hearing more from you guys. Thank you.
Right. If there's no more questions on the stream, and I'm fully aware of the time, so please ping us on our socials, ask us more questions there. We can continue our conversation, or please join our next stream. Actually, I think there's a few last minute questions that the team wants to answer. Another question from Seeking Cashflow.
Jashan.
So I'll repeat the question. Yep. Can you explain why you guys chose SPI connection versus directly CAN? So it wasn't fully by choice. The chip they're using. No, I'm unmuted. Yeah. The chip we're using does have native CAN, so it has 3 native CAN buses, but we needed way more to actually operate the robot. So what we ended up having to do was have SPI to CAN converters. I know I sound a bit sad saying this, but actually the chip we're using for this conversion is actually really good after we worked out a lot of the kinks. So far, the CAN bus has been super stable. We run 3 of these chips from a single SPI bus, running at about 17 megahertz right now, the last time I measured. So honestly, it's really impressive, and I think that this might be the better way forward for humanoid robots or maybe multi-CAN systems in the future, rather than relying on specialized chips with multiple CAN buses. You use something more common like SPI, and you convert it down to CAN. And for the specific chip we're using right now, it's the MCP2518F. It's a bit harder to find because Microchip doesn't SEO their data sheets very well. What you usually find on the market is the MCP2515, which is nowhere near as nice as the 2518. Yep, this is from Salim. The SPI CAN converters are pretty stable actually. It does the SPI to CAN translation in hardware instead of software. Has SPI to CAN CRC checks. Yep, exactly what Salim added on. It's really good. I think we had a question about AI safety as well. Okay, so from Mukul, I personally work in AI safety. I find most LLMs that we work with have just seen limited world of text, and AI that is multimodal or the data that's generated from this robot can really be a way to AGI. Yep, we agree as well. I mean, we're not sure what pathway the industry is going to take, but more data always gives researchers a lot more options of what they can try. And it's often been a limitation in the machine learning industry. So we're going to have to go through a bit of hard times getting these robots out there. But I think once they're actually out in the wild, we're going to see a huge explosion in the machine learning space.
I think we're really excited to work with people who are interested in AI safety. I think robot safety, for those of us who have kids, I think the real thing that, it's a nightmare. There's a wide variance of scenarios that you can get to, right? And, our kids hiding from a robot is not one of them. And I think we're really, really excited to, work with safety and understanding how we can not only handle just the very tactical, like don't hit a human while you're walking, but also I think on the alignment side. Maybe last question. I remember someone asked, so Menlo just fully pivoted to humanoid robot. Yeah, so I think this is something that I wanted to share, I think on our site that, we've done. So I think for us, I think for those of you who have seen Menlo Research over the last 3 or 4 years, we've basically, built a number of things from Gen to, to Cortex, to Ichigo, to AlphaGo, to AlphaSpace and everything. I think we've really started to bet very much on a humanoid robot, which can be either wheeled or legged. And we strongly believe that the humanoid robotics is sort of at that tipping point. We are probably at the BERT era of models that is just before the ChatGPT moment. And we do feel that we've got a good mix of hardware and software, and I think that there's going to be a lot of value creation from being able to have robots that take on dull, dirty, and dangerous work that none of us want to do. And I think we're really, really, really excited about this. I think the team has come together in a very, very quick period of time. And, I think we're starting to put things together. And Mando, yes, absolutely. Humanoid accidents are usually by teleoperators, right? So we've got a long way to go in all of this. Okay, seeking cash flow, you are actually the biggest, coolest electrical engineer. Like, you're not asking cash flow questions. We're actually super excited to talk to you about this in the electrical engineering section about Discord. I think we're coming on time, and I just want to say thank you to everyone for joining us, and just pass it back to Mimi.
All the community goals usually get very active towards the end. So as I'm mindful of the time, let's just wrap today's session here. We will be having more sessions in the future, so you guys please join, and we can have more Q&As there, or join our Discords and our social media channels. And yeah, thank you for joining us. I know that due to some time differences, some people have to wake up a bit earlier or stay up a bit later. So we're really thankful for your time. Thank you for being here, and thank you for joining us.